What's up? What's up? What's up? It's your boy, the network. And today's topic is subsection 3.2D, Autoconfig SLAAC. This is an acronym for Stateless Address Autoconfig. I had to go back to the memory bank for that one. It just came from Christmas break and we getting right back into it. But you know what? We still going to try to lab every day, even though we skipped a couple days. You know, it's the holiday break. Like I said, life happens. So sometimes life doesn't, or lab doesn't happen every day. Identify IPv6 addressing and subnetting. This is for the CCNP route exam code 300-101 version 2.0. Let's look at the exam blueprint to see where we came from and where we are headed. All right, this is the exam blueprint, implementing Cisco IP routing, exam code 300-101. Again, this is version 2.0. We just wrapped up, well, we didn't just wrap it up because it was like last week since we did a video. It was ND, RS, and RA, which stands for Neighbor Discovery. Well, I should have been Neighbor Discovery Protocol, but in this case it says ND for Neighbor Discovery, and RS, Router Solicitation, and Router Advertisement. Remember, those are kind of like hello messages for IPv6, but coming from routers and, coming from routers. There's also NSNA, which is Neighbor Solicitation and Neighbor Advertisement. You can watch the last video if you need further information on that. Today we're going to be doing Autoconfig SLAAC. And after that, we're going to do DHCP relay and server for IPv6. Remember, we did DHCP relay and server for IPv4. Next video, we're going to be doing for IPv6. And today, we're doing Autoconfig SLAAC. So Autoconfig, or SLAAC, is basically, it's an acronym that stands for Stateless Address Autoconfiguration. And it's a way to kind of automatically generate an IPv6 address without a DHCP server. And the way it does that is by receiving RAs, router advertisements, and from routers that are in the network, or gateways from the network. Remember, IPv6, there is no ARP, right? So RAs are kind of like messages to kind of, remember, we needed ARP to figure out what the MAC address is using an IP address, right? So since there's no ARP, we have router advertisement and router solicitation and neighbor advertisement, neighbor solicitation to figure out the MAC addresses for devices that's in the network. This stack is called Neighbor Discovery Protocol. Now, that is what is used to generate the SLAAC address. Let's, I don't know if I made that really clear, but let's go ahead and take a look at the official definition. Mine kind of cloudy right now, still on vacation, but we're going to do what it do. So this right here actually is not SLAAC, all right? This dude right here, you see him laying back right there. We have been slacking during the holidays. He even got his holiday socks on. They're not really holiday colors, but that is definitely not SLAAC. SLAAC, again, is Stateless Address Auto Configuration. SLAAC provides a simple plug-and-play connectivity where clients self-assign an address based on the IPv6 prefix. So that's what I forgot to tell y'all. A router in the network, or your default gateway, or it could be another. You could have more than one gateway now. They send out these router advertisements. You could send out a solicitation, but these advertisements come out, they come across every 200 seconds, right? So in case you don't hear from one, you would send out kind of like an ARP reply, or a gratuitous ARP is what they call it, or a router solicitation rather, and you use that to find out the routers in your neighborhood, basically. As you can see right here, it says this process is achieved when the IPv6 router sends out periodic router advertisement messages, which inform the client, which would be us, of the IPv6 prefix in use, the first 64 bits. Now the second 64 bits, okay, and the IPv6 default gateway. From this point, clients can generate the remaining 64 bits, will be like the second part of the IPv6 address of their IPv6 address based on two algorithms. It could be done by EUI-64, which is based on the MAC address of the interface, and we discussed that. That's about 2 videos back if you want to know. If you don't know, EUI-64 is a way to kind of take the MAC address, chop it up, and then put in the FFE in the middle, flip the 7th bit, and then that's the EUI-64 like suffix. Really, it's the second part of the IPv6 address. The first part will be the prefix, which is given to you by an IPv6 default gateway. That's one way to generate the second part of the SLAAC address. And then the other way is private addresses, which are randomly generated. There's also temporary addresses, but that's kind of out of scope of this exam. That's more of a CCIE written topic. I started looking into that, and I'm like, oh, I ain't got to even look into this. This is CCIE stuff. So if you look in this graphic right here, we got this IPv6 router, right? It's basically our gateway. And never mind, this is a wireless. This is a wireless infrastructure right here. But just think of it as this is the same thing as if it was a wired network. So this is the prefix right here, 2001 DB 8020, right? ::1. Now remember, this double colons right here is basically a compressed. This is basically a compressed address. They removed the leading 0 here, some leading zeros there, and they compress these zeros right here. I showed you how to do that in the IPv6 unicast video. It's about 2 or 3 videos back. Anyways, it sends out the prefix, right? That's the first part of the IPv6 address. It goes to the wireless LAN controller, to the access point, to the client. Lets them know this is the prefix, y'all. Minus the 3 and the 2. That's just their part of the address. The second part is generated by the client using SLAAC. In this case, it's like quad zeros and a 3. Quad zeros and a 2, right? Because the prefix was given to him through a router advertisement by the IPv6 gateway, right? I'll give you another example. Before we do that, let's look at different definitions of SLAAC. I don't think I really made it clear. I'm glad I added these other definitions. They just reworded it differently. You can pause it right here and read it, or pause it right here and read it, or just stay long and I'll read along to you. I know I ain't really want to be the type to just read PowerPoints to y'all, because really to understand this stuff, you really got to be hands-on, reading on your own from different sources. Don't just use one source. Remember, you got to look at, from different perspectives and different ways. It'll help you, if you see it from, different sources. With SLAAC, an ISP router could send router advertisements, which we've talked about already, which advertise an IPv6 prefix, the first part of the IPv6 address, on the link connecting to a customer router. The customer router could then take the advertised prefix, the first part of the IPv6 address, and fill in the remainder of the IPv6 address by either randomly selecting those bits or by using the EUI-64 process. Simple. That came from the official cert guide, OCG. You want to read the second part? So I think I basically explained it. That's basically the same thing. He gets router advertisement. He gets a prefix to the router advertisement and creates the second part. That's the first part of the IPv6 address. And the client himself auto-generates the second part of that, the IPv6 address. Now, keep in mind with SLAAC, it does not configure other parameters such as leasing information, DNS. DNS information, you can't get that through SLAAC. You have to use the DHCP server to get that information. And I'll show you an example of that. Not in Packet Tracer. Not actually in GNS3. Today we're going to try something different, actually. We're going to do this in Boston NetSim, the older version. I didn't have money for the new one. I just had it laying around for the CCNA exam. Here's one more example before we jump into that, though. This from Cisco Press. I believe this is an example from Sean Wilkins, right? So this first part, you might have to zoom in or whatever. That is the IP address of this router, right? Router 1. He got these 4 clients right here, H1 through 4, right? That's their MAC address, right? See those guys? I should zoom in, but all right. So the advertised prefix, or the first part of the IPv6 address, right here, 2000, 1, 2, 3, 4, 5, 6, 7, 8, ::, which means the rest of it is zeros, right? /64. Now, this router is the gateway. He is going to hand out the prefix He's not really handing it out. He's advertising it, really. Letting everybody know, hey, this is the prefix, y'all. Hey, this is the prefix, y'all. And he does that every 200 seconds. Or these guys will be sending solicitations to find out what the prefix is in case they fall somewhere between the 200 seconds and they haven't heard anything. They just going to send a solicitation as soon as they get online, right? Or as soon as IPv6 is enabled on them. If the hosts H1 through H4 shown here we're using the EUI-64 method of host identification. So if he uses EUI-64 to generate their the second part of the IPv6 address or suffix, whatever you want to call that, the IPv6 addresses were created using SLAAC. Would be, so in this case, notice I put them in different colors, right? The first part in black is the prefix, which was advertised by the router 1. This in red, not the green yet, but this in red is the MAC address. But the second digit was flipped through the 7th bit, right? This second byte right here, this is a byte, but the 7th bit was flipped. So that's why it changed from, like, say, for example, give you an example, H1 was 02, right? So now it's 12, right? Then we stuck the FFFE in the middle, and then the second part is the rest of the MAC address. So that's how he auto-generates the full IP address, because this was advertised through the router. All this in black was advertised to the router. They all received it, and then just used EUI-64 to create the second part of the address. Notice we got some double colons here, which means there should be some zeros, right? How many zeros is that? Pause that and think about it. All right, we back. Remember, an IPv6 address has 8 hextets, right? So since we've got, let's see, 1, 2, 3, we're going to skip that, right? 4, 5, 6. That means we're missing 2 hextets. That means we had 2 quad zeros in the middle of all these guys. So the full IPv6 address, all these addresses is actually compressed. It looked like a long number, but they're actually compressed. They're all missing quad zeros in the middle here. 2 quad zeros. I hope that makes sense. Moving right along. This is the SLAAC process breakdown. Again, it's the same exact thing, basically what I said. I'm just giving y'all one more example. This is the command right here that we use to use SLAAC. The command to assign Cisco router address as a SLAAC client is you go to the interface, IPv6, address, autoconfig. There's also another way to just enable IPv6 without using SLAAC, but that's just going to give you a linked local address. I'm going to give y'all an example of that. So first thing, step 1, right? It's 5 steps here. Router 1 will send router solicitation. If he hasn't heard any advertisements, remember how many seconds does an advertisement come in from a router? 200 seconds. Every 200 seconds. I'll show you all that too. Sourced from a linked local address out to the LAN. Router 1 will see this message. So router 1 right here. I was going to actually do this in DNS3, but decided to do this in Boston. We'll see this message and send back a router advertisement with the prefix to use. So he is the default gateway. In this case, he hasn't sent out an advertisement yet. He received a solicitation. Remember, solicitation is ask, advertisement is receive, or reply rather. Send back a router advertisement with the prefix to use. He says, okay, use this as your prefix. Router 2, he's going to take that and basically create the second part of the address using EUI-64. I basically sound like a broken record right now. This is just the third example for y'all. So again, EUI plus, so the full address is prefix plus EUI-64. So 48 bits of the MAC, FFFE in the middle, 7-bit flip. Router 2 will send out a neighbor solicitation for duplicate address detection. Make sure that there's no duplicate addresses in the area, in the network. And then router 2 is going to send a neighbor advertisement of his address, which is equivalent to a gratuitous ARP. If you don't know what a gratuitous ARP is, that's basically, we all know what ARP is, right? Address Resolution Protocol. Gratuitous, remember, gratuitous is basically like free, basically. So remember the word, like in Spanish, I think it's gratis or gratis. Even in Creole, yes, I speak Haitian Creole. Gratis is free. So gratuitous, now we know the word gratuitous means is basically free. And then you're giving out an ARP message without having to reply. You just sending it out. Remember, because ARP is you getting an ARP request and then you sending replies, but you're not looking for a request. You just sending out like, hey, here go the prefix, y'all. Here go the prefix, y'all. That's what the gratuitous ARP is. In this case, it's a neighbor advertisement, though. All right, so again, we're not doing GNS3. I know. We're just going to do this in Boston. So let's go ahead and fire that up. This is the topology right here. We got the core router. We're going to be working on the core router and router 3. The core router, this is a layer 3 switch. So yes, I understand this is the route exam, but this is a layer 3 switch. It does routing. And we're going to do IPv6 SLAAC, and I'll show you an example of that. We got the steps right here, and then we got a couple clients here at the bottom. Don't worry about those guys. Again, we're going to be doing stuff on the core router and router 3. Back to the instructions. You can pause it right here if you want to read the objective. I'm not going to read that whole thing to y'all. All right, we back. Again, this is the topology. We're working on core, router 3. You want to pause this. This is the commands we're going to use. Really ones you really want to pay attention to is IPv6 enable, autoconfig, which is how we configure an IPv6 address on an interface by using SLAAC, and show hosts. The rest of this stuff you should probably already know by now. First thing we're going to do is enable IPv6 on the router. Right? We've discussed that before. We're going to go to actually on the core router, right? Which is this guy right here. Go to configure terminal. And this is how we enable IPv6 on your router. It's not enabled by default. Unicast routing. So it's IPv6 unicast routing. Now IPv6 is on. I should have showed y'all what it looked like when it's off. You just do show IP, I believe, interface brief. Or you could actually just do a show run. But remember, you challenge yourself by not doing show run or show startup. You kind of try to use other show commands to kind of know where you can find the same information. Verify FA03 is in the upstate and not already configured. How we do that? Let's do show IPv6, not IP, interface FA0/3. Nothing, right? Let's just do interface brief. And right here we got FA01 we have 2 addresses for those guys, right? Link local, global. Remember globe was the 2000, right? Let me make this a little bigger for y'all so y'all can see. This guy is a link local and a global. Fast Ethernet 03 up, but he does not have an IPv6 address, so perfect. Right now we're going to assign the FA03 interface with this IPv6 address. How do we do that? We already know how to do that, but instead of IP address, we do IPv6. So Control C, configure terminal, IPv6 address. Paste that bad boy. Did we do that right? I don't know. Yeah, there it goes right there. See it? Enter. What do we do wrong here? You see what we did wrong? We didn't go on the interface. So, interface FA0/3 IPv6 address. Paste the address. Come on, buddy. Now we gave him an address. Display information about FA03 interface. Why have 2 IPv6 addresses being configured? Let's do that. Do show IPv6 interface FA0/3. What do we have here? We got this address and that address. Why? Because one is a link local, which means it's not routable on the internet. This is kind of like a 169 APIPA address in IPv4. The other one is our global unicast address. This is what we want to use to communicate outside of the network. This is routable on the internet. That address right there. Notice also that it's concatenated. So we got some quad zeros in there. That is the reason why we have 2 IPv6 addresses. Now we got to go to configure SLAAC on router 3. So let's go to router 3, which is this guy right next to us. Enable IPv6 unicast routing. Okay, well, let's read this though. IPv6 clients do not require the use of a DHCP version 6 server. in order to automatically obtain IPv6 addressing information. In this task, you will configure router 3 to obtain IPv6 address using SLAAC. All steps should be performed on router 3. Enable unicast routing. How we do that? Enable, configure, terminal, IPv6, unicast routing. Now it's enabled. So we turned on IPv6 on the router globally, right? Verify FA00 is an up state and not configured already with an IPv6 address. So we're going to do show IPv6 FA0/0. Oops. Interface. Nothing. Let's do show IPv6 interface brief up unassigned. Notice how this time we can see it because we turned on IPv6, but there's no IP address, right? So now enable IPv6 on this interface. How do we do that? IPv6. Oh, we got to go to the interface. What am I doing, man? Interface FA0/0 IPv6 enable. Not bad, y'all. All right, so verify IPv6 is enabled on an FA00 interface. What else do you notice about the interface now that IPv6 is enabled? How do we do that? Do show IPv6 FA0/0. My bad. Interface FA00. And then notice IPv6 is enabled. He has a linked local address, but he does not have a global unicast address. No global unicast address isn't configured. He's joined some multicast groups, but he has no global, so he still can't communicate outside of the network. Configure FA00 to obtain an IPv6 address by using SLAAC, which was the topic of today. This is how you do it. We've discussed it already. You don't remember? Pause and think about it. We back, or you can rewind, whatever you want to do. IPv6 address autoconfig. I'll show y'all some. This is how you can do it. You can statically do it. Statically put the link local. Statically do the first part of the address or prefix, or autoconfig. So IPv6 address autoconfig. That's how we use SLAAC. Verify FA00 has used SLAAC to obtain an IPv6 address. How do we do that? Do show IPv6 interface brief. And notice now he's got a linked local address as well as the global unicast address. Let's take a look at that though, right? We got the 2001. He eliminated a leading 0. Eliminated a couple leading zeros here. Concatenated some zeros here. And then this is the second part, which is basically the MAC address. FFFE in the middle. You flip the 7th bit somewhere in here. What do we notice about the difference between FA00's interface, global unicast address, which is this guy, and the core's FA03 interface? So we got what? 2001 DB8 C : Let's look at the core. He's 2001 DB8 C : Same prefix basically. So they're using the same prefix. Right? That makes sense. From router 3, attempt to ping the IPv6 address that is configured on the core's FA03. So we're going to go to router 3 and ping that address right there. Go to router 3 and ping. Let's get out of this. Control Z. Ping that address. Right? Enter. And we got a reply. Success rate 100%. So it looks like we're good to go. And that's how you configure SLAAC. Basically, we got one more. Display DNS server information. Is router 3 configured to use an IPv6 DNS server? Remember what I told you about SLAAC, right? SLAAC does not give you any DNS information. You still need DHCP version 6 to do that. And the way we can verify that, show hosts. And as you can see right here, Name server uses name address lookup uses domain service. Here's the name service 255.255. So basically, no, it does not have a DNS server. You would have to use DHCP to do that. So if you like this video, comment, like, subscribe to the network.